Inverter sizing. We can choose the same power of the system for the inverter or high. Also, we can choose a smaller power for the inverter to reduce the cost and oversize the inverter according to its datasheet. All same panels conditions put together in same input. Conditions like shadow, tilt angle, and orientation. This is a very important point to consider in the design. In last example, we can choose 3.6 ABB inverter. System area approximately need 10 meters square for each kilowatt for the rooftop systems. This is the inverter datasheet we will use. Inverter sizing. Now, to calculate the maximum number of PV modules per string that the inverter can afford, we use this formula. Inverter maximum MPP volt over V open circuit at -4 degrees Celsius. Back to the datasheet of the inverter, and we will see the MPP volt range. Minimum 380 and the maximum is 700. So the MPP max volt for the inverter is 700. Now, to calculate the V open circuit of the PV panel at SDC condition, we use this formula, which is V open circuit plus absolute -4 minus 25. The 25 is the temperature that used in the standard test, multiply by the temperature coefficient of the PV panel, multiply by the V open circuit. Back to the PV datasheet, and we will see the temperature coefficient 0.3% and the open circuit voltage for 5.6. So the V open circuit at -4 degrees Celsius equal to 49.56 volt. And the maximum number of PV modules equals 700 over 49.56. We will get 14.12 panels, and we round it to 40. This is the maximum number of PV modules per string that the inverter can afford. Now, to calculate the minimum number of PV modules per string that the inverter need to work in MPP range, we use this formula. Inverter minimum MPP volt, which is 380 volt, over VMP at 70 degrees Celsius. We can find the VMP of the PV panel in the datasheet. As you see, it's 36.8. So, use the same formula to calculate the VMP, but change the V open circuit to VMP and the temperature to 70 minus 25. Compute, and we will get 41.76 volt. The minimum number of PV modules per string is 9.09 round to 10. Is the number that the inverter need to work in the MPP range, and the MPP range is the maximum power point which we want to get the maximum power from the PV system. All same conditions panels together. This is a very important point, as I said before. Yellow area, almost no shading. See, the yellow area is bought together, and blue area bought together, and red area bought together. Why we can't put all the panels together? Because the power output from the panels without shading is different comparing with the power output from the PV array with shading. So we can't put all the panels together with different conditions because the power output is different. DC-AC ratio. PV designer may choose to oversize the inverter in order to maximize the power production due to the following. So, when we design the system and we want to maximize the power production, we have to consider the following: actual PV module VZ module nominal power, actual PV module power VZ nominal module power. This point means if we have a system with shadow on some parts of the PV arrays, we can oversize or maximize the power production because the PV array is not to reduce all the power from it. So we can increase the number of modules in the DC side. Financial consideration, it depends on the client. DC-AC ratio greatly depending on the location because the peaks and hours is not the same around the world. Example of DC-AC ratio. Now, the effect of DC-AC ratio For example, 100 kilowatt inverter. As you see, the blue and the red curve is for 1.33 DC AC ratio. We see that DC power is 120 kilowatt and the AC power is 100. So this inverter is not working effectively. On the other hand, DC and AC power for 1.16 DC AC ratio almost the same, so the inverter working effectively. Wires and breakers. DC cables. We can find the DC cable size by multiply the module's I short circuit by 1.56. In our example, the module's I short circuit 8.91 multiplied by 1.56 equal 13.89 ampere. DC cable length from 10 to 12 for each kilowatt peak. Let it here 15 meter. This is the table of the DC cables. Let we choose the 3% voltage drop and the length we have 15 meter and we need 14 ampere cables. We can't find the 14, we choose the 15 ampere. So go to the 15 ampere, this is the table for 15 ampere and to the 15 meter. We can choose this code. To know the size of the cable, we go to this table. Now we choose this. So we need the 4 millimeter diameter and 6 AWG. AC cables. AC cables can be estimated by inverter maximum output current multiplied by 1.25. For our example, we have 20 ampere. And according to the current, we can choose the size of the AC wire. AC cable length depend on the site, MDB location, main distribution board, and the inverter location. Circuit breaker size. The circuit breaker ampacity should be higher than the maximum AC current. The maximum AC current here is 20 and we need APB MCB 25 ampere and 300 milliampere are CCB earth leakage. Note that voltage drop across DC AC cables is recommended to be 2 to 3%. Estimated losses. The dust or soiling losses equal 30% with continuous cleaning during the year and the voltage drop 2%.